Hey there, welcome back. You came again. That means you are also excited for this PyTorch journey, as I am. So let's get started. Today, we are going to talk about tensor. And tensors are the single most important building block in deep learning. If you ever wondered how PyTorch understand images, text, audio, or video, this is where it all started. Let's begin. It means everything in PyTorch starts with the tensors and ends with the tensors. So that is why tensor are the most important. So let's start it with the definition of tensor. So what are tensor? So tensor is a multi-dimensional numerical container. That means it holds numbers, but those numbers are arranged in multiple dimensions, not just a single simple list. It is like a box that can be 2D, 3D or even higher. As we can see, scalar, list, matrix, and the dimension and those tensors that have dimensions more than 3 we call tensors. So another way to say that a tensor is just a way to store numbers in an organized shape, and the shape tells you how the numbers are arranged. Without shape, numbers are just a mess, and with shape they become meaningful. So single number is a scalar, that is 0D tensor. List of numbers, that is also 1D tensor, like a vector. A table of number, rows and columns is a 2D tensor, also called a matrix. Anything with 3 or more dimensions is simply called a tensor. So as dimension grows, we keep the name tensor. Now, why do we need tensors? What is the reason that researchers came up with this idea tensor? So the reason is simple. Real world data is multi-dimensional. A photo is not just one number, it is thousands of pixels in a grid. A video adds time. Audio has frequency and time. Deep learning needs a fast, structured way to represent and process that data. So tensor provides that structure. This is the main reason. So everything in deep learning becomes a tensor. Image is 3D tensor that have height, width, color channels. So image is nothing but have three channels, red, green and blue, and every channel is a matrix. It's a table having width and height and width. Similarly, video is also a tensor, a 4D tensor that have frames. So video is nothing but a number of frames are stacking up with each other. So it has four dimensions. The first dimension is frames, the second is channel, the third is height, and the fourth is width. So by combining all the dimensions, we have video tensor. Text is also a number, a tensor. So every text we have a sequence, then in sequence every text should be converted into some number in token IDs, and we convert that into a tensor, a 1D tensor that have one dimension. Audios are also 1D tensor. So audios are captured in waveforms, and we took samples of waveforms at time t at different timestamps, and by and that converted into 1D tensor. So audio is also first converted into 1D tensor, and then we apply modeling onto the audio data. So no matter the input type, a neural network only sees tensor. That is why tensors are the most important. Now let's move forward. Tensor in deep learning need to be fast. So if we have NumPy array, then why do we need tensors? The reason is simple. The tensors are fast. They can run on GPU, and GPU's graphic processing unit have multiple cores that runs these tensor operations in parallel. That is why tensors are really important, because they are fast as well. They are multidimensional. They can store numbers into multi dimensions, and they are also fast. That makes the tensor operations are really fast, and deep learning requires this kind of capability very badly, because in deep learning models there are millions and billions of matrix multiplication, addition, transpose. So that is why tensors need to be fast. So this is another reason. And you can see that in a model, we gave input tensor, and tensor goes into a model, a deep learning model. Inside, millions of tensor operations happens. And what comes out? Output tensor. Tensor again came out from the model. For example, probability is like 80% cat and 20% dog. So output probability. That is also 0D tensor. Everything in, everything out is a tensor. So tensor operations are the secret sauce. They allow PyTorch to process large amount of data quickly and efficiently, especially on GPU. So GPU can do thousands of tensor additions or multiplications in parallel. That is why deep learning works at all. Now, why do we need tensor with structured way to represent? What this line mean? What this line mean? So structured way to represent data is what makes tensor special. Once the structure is known, PyTorch know exactly how to process it fast. So look at the list of numbers 255, 228, and so on. So by itself, PyTorch does not know, is this an image? Is it an audio? Is it text? Is it a video? They are just numbers. Without shape, there is no meaning. Again, without information, a sequence of numbers is meaningless. PyTorch can't guess what it represents. Now give it a shape. Now what if we give it a shape that is 3, 224, 224? Immediately PyTorch understand that the first dimension represent the three channels, RGB color channels. The second and third dimension are representing height and width respectively. That is full color image. So PyTorch understands immediately these kind of tensors with shape. First, tensor help us represent data, image, text, audio, video in a structured way. Then PyTorch perform million of tensor operations on those tensors to process the data and make predictions, representation, then computation. Data alone is useless. Structure gives it meaning. Fast computation using GPUs makes deep learning possible. That is the whole story of tensors. Tensor are what? Data plus that have some structure, that have some shape, plus fast computation. That is what a tensor is. Now let's code. This is going to be our first coding session. So let's move to the Google Colab where we are going to perform coding. I hope everybody used Google Colab before. So we are going to write code in Google Colab, and first we have to import PyTorch library. So the first line of code is import torch. Torch represent PyTorch. My kernel is starting. Yes, we successfully execute our first code cell. Congratulations to all. We reach at this stage, and now in next every videos we are going to code. We are going to understand first the concept theoretically, and then we perform coding here. Okay, so we imported our PyTorch library that we are going to understand. The next step is, first we are making a scalar tensor that we understand recently. So scalar is equal to tensor 42. 42 is my number that is stored into scalar tensor. Now let's print this scalar and what else now? Let me tell you what is the shape of this scalar. As we all know, I'm just uh, I'm just telling you what are the methods to know the shape of the tensors. So let me write it. Let me print scalar. Then it is print scalar shape. So these are the things. Shape is zero. That's why it is 0D tensor. And dimension is also zero. So to know the dimension, we use ending method, zero dimension. Similarly, we can create a vector tensor. So how do we create vector tensor? We can pass a list into this tensor method, torque.tensor. So 1, 2, 3, 4. That is our vector tensor. We pass a list and then we change this to vector. Yes. So this is our this printed our vector tensor. What is the shape of this size of this vector tensor is 4 and the dimension is 1 because there is only one row. Okay, now what's next? You all know. Now we will make our matrix tensor. So these are some of the common tensor methods that we are going to use in future to make deep learning models. So these are very important. And the shape of the tensor and the dimension of the tensor is all what we need to understand from this video. Now, let me change the name matrix. Yes, so we printed our matrix tensor and the size of this matrix is 2 into 2 because there are two columns and two rows and the dimension is again 2. So dimension is very tricky part and right now we created our tensors using hard coded. I pass the numbers into this, but if we know the dimension then we can also create a random tensors. Random tensors are important. You can relate it like in deep learning models. Initialize the random weights. We can use the torque dot rand and then we pass what should be our weight matrix shape. So I'm giving the shape is 2 into 2, 3 and 4. So that is how we can create a random tensor with the given shape. So tensor 3D. So this will create my random tensors. Yes, this is very tricky. So to know the random tensor, to know the dimension, we just see that how many numbers are there. So 1, 2 and 3. So there are three numbers, that means its shape is 3. So okay, alternatively, if we can see only this tensor, then how do we know the dimension? Just count the opening brackets. Okay, there are three opening brackets, that means the dimension is 3. You can again check what is the dimension dot ending, that will give us the dimension. Okay, so that is how we can create tensors and we can see the shape and the dimension. Similarly, if I can show you that image tensor, image tensor, so we can create a random tensor dot a range. So what is the difference is rand and if you know then it is good. So rand and gives us the numbers from the normal distribution. Okay, and they can be anything, minus to positive. And rand gives us the random numbers from 0 to 1. So I'll see 0 is tensor. So you can see every number is in between 0 to 1. Okay, so that is the difference between rand and random. So this is image tensor. It has three channels that have random numbers, and the height and width is 2 to 4 and 2 to 4. So image first converted into this type of tensor. Okay. Now next we will see the indexing and slicing. So indexing and slicing, when we created a tensor, the indexing and slicing are common, are similar as in numpy array. So this is my tensor, matrix tensor. Okay. So the if I want to use slicing method, so in this code you can see that uh, we can use 0 1. Okay, so it means 0 row and first column. So it will return us 20 because this is 0 row and this is first column. So that's why it will return 20. You can see tensor 20, third row. If we want third row, see indexing starts from 0. So that is why 2 is not 2, it is third row. Okay. So 0, 1, 2. So third row is what? 70, 80, 90. That's why it return this. So indexing and slicing is very simple. We will use, if we want every element of this row, every element of all the rows, then we use colon and 1. See, row 1 to column 0 1. Can see here all rows second column. This is what it trying to say. So second column is 20, 50, 80. We want all rows. So that's why it returns this tensor. So these are the concepts of indexing and slicing. Let's also see some of the matrix operations, tensor operations. So tensor operations are also very simple in PyTorch. Let's suppose we created two tensor. If we want to perform addition, then a plus b is what? It will add up it will add up all the elements at same place. So 1 plus 4, 5, 2 plus 5 is equal to 7, 3 plus 6 is equal to 9. If we want to subtract, then again the same thing happens. Or to do multiplication, we use mat mul method. A dot mat mul and then b. So this will give us the matrix multiplication of both the tensors. So to perform multiplication, we use mat mul method. So these are the basic methods in PyTorch library. We saw that how to create tensors, we saw but how to use indexing and slicing, and we also saw some of the basic operations, mathematical operations that we can apply on tensors. Now coming to the most important thing of this video, I said that tensors used in on the GPUs. Okay, so in PyTorch, how do we see that we are on GPU or CPU? Okay, so we write this line device CUDA is for GPUs. If our kernel is on GPU, then we use CUDA for that. CUDA if torque dot CUDA dot is available, else CPU. Right now we are on, yes, we are on GPU. That's why it returns CUDA. My mistake. And let's change the run type. If we are on, if we change it to the CPU, then it will return us the CPU. So Yes. Okay, we need to run the import library again. Yes. Yes, now we are on CPU. Also, one more thing, one more important thing. If we are on CUDA, then we need to specify every tensor. Then that A, then we define the scalar tensor here. Then if we are on CUDA, then we have to add one more thing to the device. Yes. When we do this, then this tensor will run on the specific device that we are using right now. So now scalar, yes, yes. So now this scalar is on the device that CPU right now we are using, but previously we were using CUDA. So we assign this tensor to our device so that it can run on GPUs and it works faster. So yes, that is it for today. These are the simple tensor things that I want to make you understand, so that in next video we will take next important topic, and we will move ahead in our PyTorch journey. So that's it for today. Thank you so much for watching my video.